and welcome to Tech20 2023, first one of the year. My name's Roy Stenhouse and I'll be your host for today. So, effectively, Tech20 is exactly what it says in the tin. It's 20 minutes networking and lots of food, as you can tell, and 20-minute presentation followed by a 20-minute Q&A. So, a little bit of house rules before we give you the fire brief. We don't have microphones, so please put your hand up. So you'll get that sent as a link so you can see the whole thing again. Just be responsible for yourself and others around you. And please make sure you're familiar with the fire exits, which for everybody sitting facing me, it's behind you on your left. If not, it's back through this door and up the stairs. We can't take photographs today, so because you're getting a copy of the slides in my hand, can you just refrain from doing that? Normally we don't mind. So a little bit on the fire exit. As I said, it's behind you, but if that's blocked, go up there. But we actually congregate in the Bupa car park, which is 2 doors down. Follow anybody with one of these badges and you'll be fine. So a little bit about the project is going to be shared by Hayleigh Barnett. So Hayleigh is 10 years in oil and gas. The reason I'm actually employed by NZTC was as a result of Hayleigh interviewing me, so I'm very pleased. She's passionate about everything about hydrogen. She runs our hydrogen theme and knows quite a lot about what's going on in the hydrogen space, and we're delighted to have her here today to talk about the Hydrogen Backbone project. Over to you, Hayleigh.
Thank you. Okay, I'm just going to check, I think my voice is loud enough. Can you all hear me okay at the back? Yeah? Awesome, thank you. If at any point I dip, then just shove your hand up and I'll know that that's my cue to speak a bit louder. All right, thank you for that introduction, Roy. Thank you for all joining us today. I'm going to give you an overview about the Hydrogen Backbone Link project and some of the key outputs so far from phase 1 of the programme. But before I do that, I just thought I'd share some insights on actually how we got to where we are with the Backbone Link project and where it actually came from. So if you look at some independent sources like Wind Europe, we know that there's a significant portion of the low-cost offshore wind within the North Sea, particularly within Scotland. And we also know that within Europe, they're looking at an onshore hydrogen backbone link, and initial kind of studies and work that came out of that showed a connection over to the UK. Here, you can kind of see it, all via Bacton, which is absolutely a solution and should be looked at. But considering we're a considerable portion of the resources, we kind of got thinking, well, what about all of the resource that we're going to exploit here in the North Sea and potentially have tied back to Scotland? Should we be considering what that might look like as well? So here's a snippet of what it might look like. So from there, the Hydrogen Backbone Link project was born with the objective of providing that strategic connection from Scotland, either via the rest of the UK or directly to Europe for the export of hydrogen. And this is how it started. So 5 pillars of an idea of some potential scope areas, things we might look at in each of those areas. And it kind of grew from that into what I'm going to take you through today. So here's a snapshot of one of the routes that came out of the study. Massive thanks to all of our partners. Taking us from that to this is a great achievement, and we can't do it without support from industry and backing from a number of these project partners. So massive shout out to them on that front. Why is it important that we're looking at that now? So I mentioned that there wasn't that connection before. And now that this project and the team that have delivered it have been fantastic in showing that impact, we're now seeing it reflected in a number of other literature, not just our own, but other people are picking it up and showing now what an opportunity it would be to have that connection, not just into south within England, but also showing that connection into Scotland too. Before I get into the nitty-gritty of the project though, I wanted to share a video with you all. Sums it up better than I can.
Hydrogen Backbone, enabling green hydrogen projects for the UK and export to Europe. Creating a hydrogen transport and storage system is essential to decarbonise industry and deliver reliable and affordable energy for homes and businesses. The Offshore Hydrogen Backbone project is laying the foundations for a hydrogen pipeline network linking proposed energy hubs, ports and other assets with centres of demand. The project looks at repurposing and optimising existing offshore pipelines and considers the creation of new pipelines, and the technology required to maintain and operate these, such as compression, storage, blending and deblending, valves and metering. One year after commencing, the project has demonstrated that while repurposing some existing assets is feasible, further engineering, testing and operational analysis is required to verify if assets can be repurposed, upgraded or replaced. The project has already identified that a new pipeline from Scotland to Europe may be necessary. Moving forward, we must accelerate the commercialisation and development of the Scotland and UK hydrogen backbone to connect to the European backbone, maximising innovative technologies, contributing towards establishing a hydrogen economy that is estimated could support up to 100,000 jobs.
So a summary there before we delve into the details. So what I'll take you through now is some of the outputs from the option assessment, the technologies, and then some of the economic work that we've done. So here are, I'm going to go over here so I don't stand in you guys' way. Here's a snapshot of the new build options that have come out of the study. So 2 options there, side by side. Same connecting points into Scotland. So across Scotland, there's 4 connecting points there, only differed really by the route they take through waters to get across to Europe. So one is dominantly in UK waters and the other is in international waters a lot sooner. We had a look at a couple of different design cases. So 2, 5 and 10 gigawatts. What we've taken forward and some of the economics that we've run is the 10 gigawatt design case. 100% hydrogen assumed in these pipelines. If we're going to build a new pipeline, we're not looking at like a natural gas, hydrogen kind of combination, just hydrogen. And the lengths on those are about 1.4 to 1.5 kind of 1,000 kilometres with a estimated capital cost of 2.7 billion. So we're right at the start of these kind of optioneering. So that's got like a plus or minus 25% on that. So we'll be able to firm that up as the project progresses, as you might expect. On the repurposing front, if I kind of focus you on this side, 2 kind of real options here, a lot more complicated than the new build pipelines, as you might expect, trying to get the current operation of pipelines to COP and then adding on new connection lines. So what we weren't able to do was find a full repurposing line right across the UK and export over to Europe. On the far left here, the green parts of these pipelines show the parts that we think could be repurposed, combined with the yellow elements, which are the new pipelines for export. This one in the centre shows how it might look onshore too, so how we might route that through the UK from Scotland across to some connection points down the east coast. You'll see backed in there kind of reflecting some of the work that was done on the European hydrogen backbone link as well. Didn't spend too much time looking at the onshore element of this. National Grid are one of the strategic partners in this project. They've got the project ongoing, Project Union, which is much more focused on the onshore network. We were really interested in the offshore piece here. These are just some snapshots of that in a bit more detail, so maybe worth looking at when you guys get the slides, because it's a bit detailed on there. Moving on to the technology, so the project is about much more than a pipeline for sure. We had a kind of 6 technology areas that we looked at. I'm going to talk about blending and deblending and storage first. Within blending and deblending, so by that I mean if you're going to put some hydrogen into a pipeline that's already got natural gas and then taking it out again for use as hydrogen. So within that kind of space, deblending is pretty well understood and it's being looked at quite extensively by a number of projects kind of ongoing throughout the rest of the UK. But deblending is more of a challenge. We currently only found 2 technologies that we think would be suitable in that space for commercial kind of scale up and use. Feedback from developers though, the market indicators aren't there yet for them to invest commercially in that scale up of that technology. So we'll really be looking for that kind of thumbs up from industry that is going to go that way before they look to scale that up. On the storage part, large, medium and small scale solutions we had a look at. So there are options across all of them. On the small scale, we could think about things like LOHCs, so liquid organic hydrogen carriers, so storing hydrogen in another form. There's a bit of an energy penalty with that, and if you're going to do that, you'd probably just transmit or like move it as the LOHC. Metal hydrides and how we might store some hydrogen in that, but also more in medium scale subsea storage for hydrogen. So there's a number of manufacturers now looking at developing purpose-built hydrogen subsea storage tanks. On the larger scale, salt caverns are an option. There's a number of those across the UK, less so in Scotland. I think Callum is maybe one, if there is one at all, in Scotland on that front. But cryogenic storage is an option at that larger scale as well. So there are some options there that can be developed and worked up. On the compressor front, existing repurposed centrifugal compressors, not likely to be the first choice. There's a lot of challenge there around the speed of the tips of the blades with hydrogen, just given the different chemical composition characteristics to natural gas. However, with everything, there's opportunities for development there. So new centrifugal compressors, potential turbo designs, which better handle the need for the increased kind of speed with the hydrogen systems. What is emerging kind of as the front runner in that space though is reciprocating compressors. Again, challenges and opportunities there. So challenges with that, footprint and cost, kind of the two big ones, but opportunities for more compact design, and also opportunities for even thinking, moving away from mechanical compression to systems like electrochemical compression, where there's no need for moving parts. Onto metering over at this side. So the scope for metering summarise that existing designs are suitable for a hydrogen system, but potentially not on the repurposing element. Some challenges there around recalibration for a different system, just given the different characteristics with the different gases, and definitely different approaches need for fiscal and non-fiscal metering there. If you were going to look to repurpose, for example, you would definitely be looking to do it on a non-fiscal basis, just given the increased accuracy you need around fiscal metering. What is needed here, though, is a clear qualification and testing mechanism for these meters, both on a repurposing but on a new build system as well for hydrogen service. And that kind of ties nicely into valves, so that's something that's also needed within the valve space. So we need a industry-wide way to qualify and test valves for hydrogen use. Similarly to metering as well, we do think repurposing is possible here. Obviously, if you have an issue with your valve already, it's likely just to be worse with hydrogen, particularly on the leak front, so we wouldn't suggest it in that case, but the existing designs should be suitable for hydrogen. There's nothing significant in terms of incompatibility, but there are some areas where we think we could look a bit more into detail just to make sure. So for example, the valve trims and some of the seals. But as with the other bits, some opportunities for new tech as well, so stemless valves there.
The final part we looked at in the technology was safety studies, and we took this in two kind of portions. First on the regulations. So onshore pipeline wise, there's work being done there already.
They're kind of covered. Offshore perspective, not so much. But there is a consortium looking at doing that just now called H2 Pipe. So they are developing specifications and regulations in that area to help with offshore operation of hydrogen pipelines. There's another group that's been convened at the start of this year as well, looking at green hydrogen at scale, particularly onshore, to understand some of the safety challenges and maybe some of the gaps in the regulations and specifications there to support the deployment at the scale that we would need for this kind of opportunity. On an operational front, we kind of took an approach to this one where it's, let's look at some key safety areas for natural gas and compare whether hydrogen is more or less favourable across the piece. So as you might expect, there was some key areas where hydrogen was less favourable, for example, with leakage and flammability. And what this allowed us to do, given the level of the project that we're at, is identify the areas that we really need to go into more detail as the project progresses through the phases. A couple of the areas that we do that are highlighted as key gaps is around detonation, detection, embrittlement, the need for inspection tools and how we might do that moving forward with offshore pipelines. All right, technology done. Economics. I know a lot of people are interested in how the economics might stack up on this. So over on the left-hand side here, using our 10 gigawatt base case, assuming a 90% utilisation of the pipeline with a 6% return, your implied tariff for that would be 32 pence per kilogram of hydrogen. We did a number of sensitivities across that, so you'll see here that corresponds to a 5-year kind of build out, so taking 5 years to ramp up to that. You can lower that if you can build up much sooner, but if you take longer, It's less favourable on the economics, as you might expect. The 3 columns here represent different return rate values. Then on the investor front, so what's really important to us as a project and a programme is that we start addressing challenges that investors might have early. We don't want it to get to the end of a couple of phases and everybody's like, well, hold on a minute, this is totally uninvestable, what are we going to do? So we had a look at some risk categories and each of the kind of components in there that might be worrying an investor and how we might address that going forward. We held a workshop on this with the key project partners, and from that it was identified that market was the piece that was worrying most of the people within the room. How might the market development go? What are the challenges that might arise from there? So just a snapshot, I don't expect you to read all that, don't worry, just a snapshot of what the kind of market output looked like and some of the key elements that kind of went into that and where some of the challenges were. So there were some comments around blue hydrogen versus green hydrogen. Is it a blend? Is it one or the other? What does that look like and how might that impact your market and the demand? There were some issues around general fugitive emissions right across the system and how you power some of the components that you need to develop this system and actually transmit the hydrogen. Some other things around the Scottish market in the global kind of sphere, how does that compare to some other markets? So all kind of credible areas of concern that we'll look to address and overcome, well, address, can't overcome all of them, but address as the project moves forward. But overarching was this sense of, is the opportunity here, the Scottish opportunity, is that well enough communicated generally, not just within Europe, but globally in terms of what we have here, capacity, skills, experience-wise? I know that's something that we're looking to address anyway as a centre, just supporting, kind of getting that message out there, what can be done. So how might we get there? What could this kind of build out look like? So we're almost at 2025, so hopefully by then we'll see some hydrogen projects coming online, maybe 500 megawatts, 1 gigawatt if we're very, very lucky. Wind-wise, so there's 6 gigawatts at the moment, offshore-wise, planned and near to being online. So you'll see a couple of diagrams there from the Scottish Government's energy strategy that show some of the pipelines for wind development across Scotland. As we step that out towards 2030 and 2035, we hope to see this kind of ramp up across all of the areas. So 2030, 5 gigawatts in line with the current Scottish Government target. And as we move out, so 2045 is the next target line. So there's 25 gigawatts of hydrogen there. So that's just showing that kind of ramp up and how we might expect that to step up over the next kind of 10 years. Similarly with wind, so using this kind of 6 gigawatt that's near to market as a base case, we hope that going forward over the next 10 years, we'll start to see some of the INTOG and ScotWind developments coming online. We've got another project here called Energy Hubs, and that's looking at strategic locations across Scotland to provide hubs for energy production, and we're hoping they'll start coming online from 2030 onwards as well. So what does that mean for this project in particular? Along the bottom here in green, over the next couple of years, 5 years, if we want to see this as a realised opportunity, we need to start addressing some of these gaps and challenge areas that we've identified here in the first phase of this project around the regulations, around the storage. Storage in particular, it's a national challenge, not just a challenge for this project for sure. And then we can start realising this opportunity and looking for build out towards 2030, probably, to be honest, 2035, pushing towards 2040, in particular if you think about it as a 10 gigawatt opportunity. But as with all of this, there is the opportunity to pull this in, particularly on the development of the pipeline, if we can develop and exploit some of this wind resource quicker. Okay, so what's next for this project? We have a number of reports now that have been developed as part of phase 1 of the project. The team are working super hard to put together a public dissemination report on this, which will be available Q2. I'm looking at Callum. Callum Milne's the dedicated project manager for this project, so I don't want to tie him to any deadlines that are not going to work. But yeah, Q2 is the target for this report at the moment. So I've showed you kind of the technologies and where I think they are. So here's just a high-level summary of that. But where we are in this project now, coming to the end of phase 2, looking to progress, phase 1, sorry, looking to progress into phase 2, is a really critical point in the programme. So you see what we've kind of developed and delivered so far. But as we move from phase 1 to phase 2, it's like a checkpoint for us to make sure that we've not missed anything in the scopes. We've got the chance to bring some things in if we have, and really to get that industry engagement again, people who see this project now and think, actually, that's one for me in my organisation. I'd really like to be part of what you guys are doing going forward. So I want to share with you just like a snapshot of what phase 2 is starting to look like. I'll get out of the way for people who kind of can't see. So it's kind of in 2 buckets there, the study scopes and then the technology scopes. So the technology one's looking to bridge some of the gaps that I've kind of identified so far and we spoke about. But on the study piece, looking to progress some of the work we've already done, again, filling in those gaps. One thing that Roy wanted me to really point out to you guys is this new addition to the scope. So definitely an area that we kind of missed in the first one, like where is the other resource nearby that we could use to kind of support and develop it and really accelerate and fill this pipeline. So if you think about, I'm actually gonna, I'll flick back. So if you think about where we are, we're almost like a bridge. Like we're kind of stranded as we are as an island, potentially without these pipelines or a different export route. But Ireland's even more stranded, and we're almost like a bridge and a gap between them and mainland Europe, to be honest. And they've got significant resource off their coast as well. So should we think about how we might tie that in to what we're doing too? So that's an extra area of scope, if you think about gaps that we might look to cover on this one. But yeah, really key point in the project. If you think this might be for your organisation, let us know. We're keen to talk with people who want to come on board. We've got a really strong consortium as it is, so we're just looking to strengthen that, build on that, to be honest. So final one from me. So we have the ambition here. We've got scenarios from the Scottish Government that show they would like to see this export opportunity and how might we connect to that. So you'll see over there on the right-hand side, the kind of 94 terawatt hours that they would like to see exported. We've got the North Sea transition deal, and they highlight what this opportunity could mean in terms of even delivering 5 gigawatts in 2030, 4 billion of capital investment, and up to 8,000 direct jobs by 2033. But we also have a lot of things here to make it happen. We've got the people and the skills. We've got a fantastic energy industry that have the skills, have the knowledge to be able to transition and deliver this as an opportunity. We have the projects where we can harness the learnings, do it better and quicker, position ourselves as kind of front runners and real global leaders in the export of hydrogen. And we also have an opportunity to anchor a lot of the technology in the manufacturing here too. This is a massive opportunity for everyone. And if we kind of start getting it right, there's so much that needs to be done here to deliver it, and not just this project in terms of the realisation of the whole hydrogen economy. So if we get that right, we really have an opportunity to anchor a lot of the technology and manufacturing here in Scotland. So that's kind of it for me. Look forward to seeing how this project how we go forward with it and the impact it has on us realising the hydrogen economy here. So thank you for your time.
That's fine. Open the floor for some questions, but Hayleigh's done a fantastic job. That's 15 months worth of study work in 20 minutes. So let's just not pretend that's a lot of information we've tried to distill. But the Q2 report will actually highlight the majority of the detail. I know Callum's struggling to get that done just now. But it's a fantastic project. I have a couple of questions, but has anybody got questions before I open the floor? Stunned silence, it's a steel bit. Oh, here we go. Excellent.
I was quite interested, so you've talked about deblending.
Yes.
What is the driver for deblending if you're talking 100% natural hydrogen pipelines and how that fits into the mix?
So for the new pipelines, it wouldn't be. Deblending would really only be applicable on some of the repurposed lines, and it would only be needed depending on who your end user is. So some of this hydrogen might go into vehicles, for example. So you might look to take the hydrogen back out of the natural gas blend and use it in its component state to fuel vehicles. But a lot of the projects ongoing kind of throughout the UK are looking at using that blend directly in heating, for example, industrial or homes. So in that instance, you really wouldn't have to deblend it, you would just use it as it is. So the deblending and the blending across the lines, whether or not we would need that is very dependent on the options that we would choose to take forward.
I've got a similar question really. It's kind of like a chicken and egg because this is really interesting stuff, but the end user. I mean,
Yes.
heavy industry is quite slow in a lot of complex tasks, fuel switching, and what's the predicted demand or the uptake going to be? And it's difficult for companies to switch fuels without the infrastructure, but it's also difficult to justify the infrastructure without the demand.
I know, right? That's a fantastic question. And so,
So, no, but I can help with this because we're actually in the throes of discussion of matching European demand to Scottish supply to actually bridge the gap. So there's a piece of work we're actually just right at the beginning of, and we've got most of Europe banging the door saying, if you can show us where we can get it from, we'll put the demand in place to help get us there. The same challenge around, we just did a gas turbine on Monday, or last week, running on biomethanol as another example. We know the biomethanol's not there yet, but we've just proven the technology can get you there. And if you can buy the fuel from Europe, you can probably cut your carbon tax that you're hit with in 2026 anyway. One of our partners, to Spirit, said they're going to be paying 62 million in tax by 2026 unless they move away from kerosene when they can't burn methane. So there is a chicken and the egg here, but we're working really closely with all the governments to get this European demand lined up to the UK. It's a piece of work that we're pretty confident that the people in Europe are asking us to take lead in, and the government on this side are saying, okay, if we can do that, we've got an opportunity to help do that. Because at the moment, we know there's a chicken and egg at this present time, because this pipeline has got a lot of interest, as you can see in the room today, but externally we've got investors, we've got energy companies already banging the door down right now to actually try and do something very, very quickly with this. And there is a bunch of challenges. But yeah, that is a big one, but we're trying to marry that demand piece just now in market, really trying to marry that up and actually see it's there so that we can connect the potential supply.
see, just building on that, I think the picture is slightly different actually in Europe versus here domestically. We're still waiting for some guidance for our market indicators here within the UK for sure. Europe, I think, are slightly ahead of that, to be honest. They want hydrogen yesterday, and so their markets are slightly further along in terms of acceptability, readiness to switch, than some of the ones are here in the UK, would be kind of my personal interpretation of it.
Another quick one, let other people join in. Are other countries in Europe seeing more incentivization by the government for early uptake?
So I think so, yeah. And they're seeing stronger indicators from their governments that that's the way the market's going. So in terms of the industrial fuel switching, I think they're further ahead in their thinking because they've been given those clearer indicators that that's where the market's going, so get ready for it. For example, here we're still waiting to find out guidance on transport and storage, and that's not likely to come until 2026. And that doesn't seem that long away, but if you look at the picture for 2030 and we've got targets to have 5 gigawatts by then, that really needs to come in. And I actually know the UK government are working on how can we bring that in and get those decision points done sooner, but that's a big challenge for the domestic market. Oh, we've got a couple. Your hand went up first.
Nice overview, by the way. Lots being involved with this one. I know there's a lot of moving parts.
Try to distill it into that.
It was just to touch on your comments at the end towards phase 2. I guess being involved with this one, you naturally look to who else has done this kind of thing in the world, and one of the pipelines that has been talked about or has reached similar levels of definition, I think, is a Norway pipeline running from Norway to Germany or something to that effect. Is there any? You talk about there's an Irish synergy here.
Yeah.
Is there a Norway one as well that's being considered?
Yeah, absolutely. There's an entire North Sea synergy that needs to be considered. So Norway, Denmark, how do we tie everybody in together from a production and demand angle? So I think what recent kind of energy challenges have shown us that going forward, cost is always going to be a big driving factor, but security of supply and resilience in the system are going to be key too. And it's something that within our team, there's a couple of members working on what like an integrated North Sea strategy might look like. So tying in with Norway, my colleagues down next week presenting to a Norwegian delegation about how we might do that, what that could look like. So not just what we've got going on here, but tying into the other regions as well. It's really, really important. Yeah, super important.
We'll go for you first.
two questions.
Yeah, go for it.
Overview, really fascinating. This is all very new to me.
Awesome.
I'd like to, if you can share a bit about who the investors are, where the funding comes from, and also what's your thinking about who will then own, operate, and maintain this once it's ready?
We haven't signed them up yet, so we're still working through. So we've got an NDA in place, and we're working this our way through. But you can imagine any major midstream operators interested. But we've got some investors in Japan, we've got some energy companies in the UK, all very, very serious about trying to get this to a different place. So in terms of how phase 2 will work, we're looking for cash. If we can't do this activity, we get 50% from government, and the other 50% has to come from industry. But if we've got an opportunity here to build out sooner because we've got the investor parties lined up, hence the investor due diligence, what can we do to help? And that was undertaken by Worley. We're confident that we can then start to release that information later on. But right now, we are just working our way through it because we want to retain a little bit of control for the UK on this. We don't really want it to disappear because there's a real opportunity here for everybody to get. The energy transition is so big. We believe the pipeline is just one piece of that, and it's a huge puzzle. But yeah, at the moment, it's all being discussions, but they're all very positive. There's a few meetings lined up that we just have to get through before we can say anything about where this might go. Sorry, I just can't say.
No, that's good. So this project sits in like a programme that Roy oversees, so it's like one of 7, and that programme is 50% funded by Scottish Government. And we're looking, and what we have to do is match fund that with industry. So that's how the first phase of this project's been delivered, 50% Scottish Government, 50% with the partners that I kind of had it early in the slides. But as Roy said, like that's the plan A mechanism for moving forward. But if other people come on.
I mean, we spent 12 million in 15 months on studies. That's how much money's come in and gone out, and we've got another 10 million this year and 10 million next year, basically, to get through. I mean, it's a fantastic programme, but it's been well supported by industry. We're really quite pleased. If the stats are, there's 66 organisations supporting us cash, more or less cash and in kind. So from energy companies right the way through the supply chain. So it's really fascinating piece.
And you had 2 questions, right?
Yeah.
We'll come to you next.
The second one was about what you're thinking about who will own and operate. And
Oh,
maintain
sorry.
the-
You kind of covered some.
Yeah, it's going to be a midstream, right? But it might be a midstream that gets support either from us, as in the government side. It might be a collaboration. There's people who do this for a living are the ones that should be doing the operation and maintenance. And we've got to try and bring some other technology along. It's a big trunk line. Yeah, and if we can get the collaboration right, we can get the digitalisation right, because I don't think we're going to do this with traditional methods, then there's a real opportunity for us all to benefit. So, but it will be midstream.
Thank you.
Sorry.
I had a question about energy security, and I wonder how you factored in the focus on energy security over the last year or so since the Ukrainian situation, and how that has impacted the likely timeline for the UK having sufficient domestic production to have excess available for export into the continent. How have you factored that in?
Yeah, so at the moment, we can just kind of go on the targets, the kind of 5 gigawatts by 2030 and then 25 gigawatts towards 2045. What we're looking at are the scenarios that have been set out by the Scottish Government and how we might reflect them in what we're looking to do. So their hydrogen kind of scenarios show export in addition to local domestic use and demand. And so we're reflecting that and what we're doing kind of in the literature here. What I personally think we have the opportunity to do is bring some of that in if we can accelerate some of the wind deployment, because we're talking about a 10 gigawatt pipeline. We're not going to send the first 10 gigawatts that we have here over to Europe. That's definitely not going to happen. So we need to find that balance. What would we need to do and how much could we bring it in to be able to meet our domestic demand, depending on the market indicators and where the kind of overarching legislation and government goal on where hydrogen is going to be used, and then how do we kind of couple that with the export. So I think it's not fully defined yet, it's like a moving target, but we are definitely considering that in how we build the pipeline out, particularly as we move into this next phase, a bit more concrete on where we might get the hydrogen from and kind of the timeline towards that. Hope that answers your question.
Yeah.
We're not entirely sure with the moving kind of targets and how it's going, but we definitely have it in our mind.
You refer to the Scottish Government targets, I'm not sure when they were set and how much consideration they took of the change.
I think that's probably why Europe's so interested in this.
Yeah, maybe a bit more immediate for them.
Yeah. So. Yeah.
2020 they were initially set. The energy strategy just came out earlier this year, like the Scottish Government one, but the scenarios that I had up there were done in 2020, so slightly, a couple of years ago, to be honest. But I think like the indicators we're getting from our kind of conversations with Scottish Government are they're very keen to realise both the domestic and export market, and whatever they can do to accelerate that, they're kind of looking to do.
I think having an export opportunity is great for the
Yeah.
UK PLC. So
Yeah.
Absolutely.
a great factor, but that overriding energy security thing could kind of keep everything in house, so to speak.
And I think we'll probably the challenge I think we've got is we've got Europe quite ahead of us in thinking of what they're going to do with hydrogen. We're still debating if we're going to put it really into the grid. The Project Union obviously supporting us and understanding how our onshore distribution network, remember the distribution network onshore and it's an export transmission network offshore. So we are working with them, but they're the ones that are trying to decide just what the impact of bringing hydrogen into the system would be, and that's where the blending comes into it. It's likely to be blended to come onto the onshore. The question is, are we going to be ready for so much hydrogen? We can't do anything with electrons; they just don't go far enough. So we'll have to change that to some sort of other molecule, if it's hydrogen or something else. And that's where the alternative fuels maybe end up being a question. At the moment, this is all study work, a little bit of technology, I think we'll be in a good place to probably pivot to whatever direction we need to go to support whatever the demand is at that point. I mean, the gas price is what, a third of what it was, an eighth, a quarter of what it was 6 months ago. It's down to £2 something. So it's anyway. But yeah, I think what we're doing, we can pivot. Is probably the answer very quickly. Goodness me. Yeah, go for it.
On the supply side, how much interest and engagement have you had with the Scotland and developers?
So not directly via this programme. The kind of the boundary of this project we had to set it somewhere, so it's more like from point of export, like we have hydrogen. But across our portfolio, we do engage like right across the production piece, in particular like my counterpart in renewables. He spends a lot of time talking to a lot of the developers and establishing those relationships and helping them understand how hydrogen might play a part in their developments, and how it could be an export option for them. So not part of this project, I think that's fair to say.
No, it is. The Energy Hub project is one. Yeah, Energy Hubs is engaged with them, but again, up until all the Scotland was announced, that was a year we've been working way in the background trying to understand what an Energy Hub is, because Dan's not here today, but still haven't defined what that means yet. But we're looking at the building blocks, and clearly, if you're looking at Shetland, let's make it dead easy for you. Shetland has no export route for all that electricity, so they're going to have to do something different, be it alternative fuels or hydrogen or something. It's just electrons stranded. That's the issue. So they're engaged. A number of people engaged in Shetland, but they're just so early in the process. They only got announced, and and NE1 was delayed, for example. So it's only now we're starting to gain that traction. And again, that's why marrying up this pool from Europe to where we can produce it could actually accelerate, or at least give you the insight of, okay, what could you do if we've got somebody willing to take it? Because it's no investment, you're not getting investment unless you're an off-taker. So if we can marry that demand supply up, then I think we can accelerate these things and actually harness the ability. The challenge is it's pretty tough waters for a floating system.
We had three more over this side.
Yeah.
We've got 4 minutes left.
You were up first. I'll go here.
Yeah, go for it.
It's about carbon footprint for this technology, right? How much we are offsetting by using this technology comparative to traditional wind or any other technology?
Yeah, like embedded carbon in the overall system.
Like carbon footprint offsetting, why this technology is better than comparatively
Then
than the other technologies?
the next one. So I don't have the number for that. I don't know if you guys did that. But yeah, it's something we can get back to on. So if you think about like 10 gigawatts worth of energy, like clean hydrogen, no CO2 on usage, compared to 10 gigawatts worth of natural gas that might be used in the same way,
we could do that calculation for you for sure. I just don't have it at my fingertips. But
But with all these changes and new infrastructure, because that might introduce new carbon, right?
Yeah.
Right.
So you're looking at societal cost
Yeah,
of,
yeah,
of yeah. So we're looking. We're trying to build a calculator that understands exactly the societal cost of CO2 for this. There is a challenge, but you could look at green cement. There's a company even local here in Aberdeen that's looking at low carbon cement of almost repurposing ash. You know, there's other technologies you can employ. So what we're trying to do is build up a societal understanding, because you know there is a fair challenge. We've actually deployed all that CO2 in say an offshore asset. So why should they be forced to then decarbonise? Because it's there. Why not repurpose it? But we are trying to understand that, because it is a big question. But you know, you go to Rotterdam, they're putting in beside the steel network, they're actually putting in an electrolyser to power the steel plant. You know, so they're already looking at low carbon solutions in order to provide the materials for this. So it's not an exact science, but there's a very serious drive to take carbons down when we're actually looking to build this infrastructure. It's a major infrastructure. But if we don't have to deploy a vessel that's running on diesel to do the inspection, and you can do the autonomous inspection or remote inspection, then maybe you're driving down the operational CO2 as well. So all of this has to come together at some point, and you know, understanding scope 1, scope 2, scope 3 emissions, because your scope 3 emissions is somebody else's scope 1 emissions. Yeah, so it's trying to bring all that together, and it's not an easy picture. We've actually started. One of the team has actually started building up what that looks like, but it's going to take a little bit of effort to really nail it down. I completely agree. The societal costs we've got to weigh up in this. Sorry, we're over here still, and then we'll come back over here.
Just a quick question. So I was at the Hill conference last year in Glasgow, and the guys from Norway and Germany were there, and their big concern is they all want to do hydrogen, but they haven't got enough people to make electrolyzers at efficiencies.
Yeah.
How much is the Scottish Government actually going to take on board? See, if we need this seriously for our country, and all of Europe's doing this, so you can get that investment, they want to do that backbone there, that you can make the hydrogen. Is that something that's being asked for by the investors?
So yeah, so the supply chain is a big challenge right across the piece, particularly in electrolyzers. So within the UK, you know, there are a number of organisations that have the capability to produce electrolyzers, but it's the scale up and the manufacturing that's a real challenge. The Scottish Government have done a lot of work recently, particularly on electrolyzers, understanding the full supply chain, so the different components and what companies within the UK, Scotland can already manufacture those, and how they might come together to really ramp up our ability to produce electrolyzers here within Scotland. But it's wider than that too, and like so Scottish Enterprise, you can see Arena over there, have had a look at the organisations across Scotland to really understand who can do what and what they can bring to the different parts of this puzzle. So yes, in Germany, in some other countries, not just in Europe, globally, China for example, are really looking at how they can ramp up the manufacturing. It's definitely something that's being considered here too. But the mechanism to support the supply chain for actually how they do that in practicality needs a bit more work. But it's definitely something that's like on the agenda.
I think Scotland's facing the same challenge with the fabrication of the main assets.
Yeah.
Right, so there's one question, then we'll come over here.
Yeah, thank you for the presentation. It's just a quick one. It's we showed some of our assets on the infrastructure that we have here.
Yeah.
And we know the UK is falling a little bit behind the European countries with reblending, repurposing, whatever it is. How do you prioritise, or how do you show the focus where on the value chain, like what we should do next to the UK? How do you bring that forward? How do you prioritise it?
So it's a really good question, and one that the government are asking as well. Like, where are the areas that are almost like no regret spending? So you know that regardless of what happens and where the decisions are made, what can we be getting after now? That means we're not going to regret it in the short term or longer term. And electrolyser manufacturing is one of those areas. Another one that's kind of emerging as a gap across the market is liquid hydrogen transport and storage. So I was at a meeting, I guess a month or so ago now, where it transpired that there's only 3 people in the whole of Europe that can drive large-scale liquid hydrogen trucks, which seems wild. Particularly when like cryogenic storage is one of the big areas or the ways that we might transport hydrogen. So
there are some areas like that where we can upskill people now, where we're going to need it for sure in the emerging market, but it's a difficult one to nail down and get right. I think we had 2 questions over here,
Yeah.
Roy, and then that's
Yeah,
us
we are out
out
of time, but we're going to
I can
allow
see
you questions.
Rona
no more
nodding at
hands
the
up.
back, like, yeah, so leave
So
your
we'll
two
go with the
to
gentleman at the
last.
front, sorry, then we'll come back to you.
Okay, given your vision of how the European market might develop in the longer term, can you foresee a situation where you could get spot market, forward markets for hydrogen prices?
I can see anything
I
happening.
mean, that seems to me to be a logical outcome of your vision as presented today. I'm old enough to remember when the idea of spot and forward market for gas in the UK was in Europe was, oh no, we can't do that. You need just a long-term contract. But if we follow what happened in the gas market, wouldn't the same happen in the long term with hydrogen? Question.
I know it's a valid question. I think it will come down to how the governments invest in this. And actually, if you think, if you go far enough back, BP was British Petroleum for a reason. My gut tells me that the governments are looking at the gas network, the gas market just now, and thinking, if we put the investment into, say, 50% into 09 infrastructure, then we can maybe drive. But it's a tough one because the whole economy needs to drive that way. Otherwise you will then be in a position selling to whoever the highest bidder is. But if you put an export pipeline, then you're tied to whoever's buying it in Europe. So there is a challenge there, I get it. I just don't know if we're in a strong enough position to make that call, because I think the energy transition is so big, it's going to need government support. I don't even think the big energy companies out there, the people that are making the billions, can actually afford to do this on their own. It's too big of a risk. So I can't answer it right now, but it's a fair addition to the vision, I would say. Sorry, yourself at the back there, sorry.
2-part question, if I may, on pipeline repurposing. In the last month, I've heard at least 2 assessments on the relative costs of repurposing versus new. The first was what I think was a ridiculously ambitious 10%. Repurposing would cost 10% of building new. And the other was possibly a slightly more realistic 35%. Be really interested to understand what your analysis across the whole project tells you about that.
So
the second point, if I may, is a risk and an insurance question. If we can find a suitably located 20-year-old gas pipeline that would fit as part of a repurposing exercise, and we undertake whatever upgrading and remedial works are required to that, has anybody asked the insurance sector what they think about covering the risk associated with that?
So I'll answer the second one first. So we've had some feedback on the insurance. I think it's actually in the detailed slides, but actually the insurance market's not ready for this. It came out of the investor analysis piece. The insurance company's not ready for hydrogen, so there is a gap in the market how you'd manage that. So, but I think touching a little bit back on the repurposing, absolutely gas pipelines are the ones you'd want to go for. They're probably the cleanest and probably the most healthy. We know that oil lines, you're probably not going to want to put clean green hydrogen into an oil line. You'll never clean it anyway. But what we're seeing is that the challenge around repurposing is all about this COP date. And it would end up being a blending, deblending conversation in order to achieve that. But there's definitely gas lines out there that you would consider for probably seasonal storage. That's what I would see the hydrogen pipeline network being repurposing is for future hydrogen storage, because I don't think we'll want to store the volumes we're talking about on an onshore site. That's an opinion, right? But what we have done is assess the fact that we can't repurpose unless they're close to end of life. But we don't want to repurpose an oil line, and it's just not. We just don't want to clean up the hydrogen after we put it in there. There's a chance we'll even put it in a gas line. You'd have to clean it, which is just an additional inefficiency in handling hydrogen. Okay, I'm really sorry. It's been fantastic, but we're all closed for the day. 20 minutes are up. So thank you very much for your questions and things, and thanks for attending. Thank you.